Okay, we'll start this video about methods of analysis. Methods of analysis. Basically, we have two methods. One is mesh analysis, and two is nodal analysis. Okay, so let's first talk about the mesh analysis. We apply KVL, Kirchhoff's voltage law. Loop currents are unknown. Okay, so we apply KVL to determine the unknown loop currents. Let's have a circuit of, let's say, 3 resistors and we have voltage sources minus minus plus plus minus. Let's say this is E1, this is E2, and this is E3. Say this, we have R1 here, R2 here, and R3 here. If we look at this circuit, we have two loops. Okay, we have two loops. This is loop, let's call it I1, and this loop, let's call it I2. Okay, so if we look at these two loops, current passing through R1 is I1. Current passing through R2 is I2. How about the current passing through, current passing through R3 is R2. How about the current passing through R2? Now this is the current passing through R2. And this current, or this branch, the branch R2, passes through R2 two currents. I1 in the same direction as the current passing through R2. However, I2 is in the opposite direction. So the current passing through R2 is I1 minus I2. So I1 is passing in this direction, while I2 is passing in this direction. Okay? So if we apply KVL to loop I1, so E1 is in the same direction, so plus E1. E2 in the opposite direction, so E minus E2. Now, This is plus, this is minus, and this is VR1. So we say minus VR1. And again, minus VR2. Well, this is plus, this is minus, and this is VR2. Okay? Now, this should equal to 0. So, E1 plus minus E2 minus VR1 is R1 I1. VR2 is R2 I1 minus I2. Thus, I1 minus I2 is the current passing through R2 in this direction, so that's why plus minus here. Okay? And this is equal to 0. Rearranging will give you R1 plus R2 times I1. Okay? Minus R2, this is R2 here, times I2 is equal E1 minus E2. So this is an equation, okay? Equation regarding loop I1. Look at it again. We're taking loop I1, summing the resistors, all resistors in loop I1, R1 and R2 times I1. We're talking about loop I. So R1 plus R2 I1 minus the relationship between loop I1 and loop I2 is R2. So minus I2 times R2, which is R2 is the resistance between or sharing both loop currents. So we say minus R2 I2 is equal to the sum of all voltage sources, E1 and E2, E1 in the same direction of loop I1, so we give it a plus sign, while I2 is in the opposite direction of loop I1, we give it minus. If we apply that, if we apply the same rule, apply KVL to loop I2, what we get, we do the same. Now we're talking about I2, so it's plus R2 plus R3 I2. Let's look. So in loop I2, we have R2 and R3. We add all of them, all resistors in loop I2, and multiply it by I2, taking a positive sign, because we're talking about loop I2. Now I2 shares loop I1 through resistor R2, so we say minus R2 times I1. Okay? So we say minus R2 times I1 equal to the sum of all voltage sources in this loop. So we have E2 is in the same directions of loop I2, so we say plus E2. And let's look at E3 is in the opposite direction, so we say minus E3. Okay, and this is equation 2. So we solve 1 and 2 to determine I1 and I2. Okay? So let's take an example and apply mesh analysis. Example. Let's take a resistor here, a resistor here, a resistor here, and let's have something like this. Let's add also add a positive source here. Plus, minus, let's have here 100 volt. Let's have here 6 ohms, 3 ohms, okay? And let's have here let's say 12 ohms, okay? Minus, plus, let's assume here we have 50 volts, and minus, plus, minus 30 volts, okay? Find the current in the 3 ohm resistor using the method of mesh analysis. Okay? What we want to find the current in the 3 ohms resistor. So this is I 3 ohms resistors. Okay? Now we have 2 loops. This is loop I1 and this is loop I2. Always we assign the loops in the clockwise direction. Don't forget that. It's very important. Assign the loops in the clockwise direction. Okay? So, according to this, we want to determine the current in the 3 ohms resistor. So I 3 ohms, actually it is equal I1 minus I2. Why? Because this is I1 in this direction, this is I1, while this is I2. So I1 in the same direction as I 3 ohms, while I2 in the opposite direction, so we say I1 minus I2. Okay? Now, loop I1. We will write the equation of loop I1. How many resistors we have in loop I1? 3 ohms and 6 ohms. So we say 3 plus 6 times I1 minus. Which resistor shares loop current I1 with I2 is the 3 ohms resistor. So we say minus 3 I2. How many current voltage sources we have? We have 100 in the same direction and 30 in the opposite direction. So we say 100 minus 30. So we have 9 I1 minus 3 I2 is equal to 70. And this is equation 1. Now we go to loop I2. Okay? I2. I2, what we have? 3 and 12. So we say plus 3 plus 12 I2 minus. I2 shares I1 with the 3 ohms resistor, so minus 3 I1 equal to. Now we have 2 voltage sources. The 30 volts in the same directions, and the 50 volts also in the same direction. So this is the 50 volts direction, and this is the 30 volt direction. So 30 and 50 are in the same direction. So we don't say minus 50, we say plus 50 because in the same direction. So this will be minus 3 I1 plus 15 I2 equal 80. And this is equation 2. Okay? So we have two equations. Okay? 9i1 minus 3i2 equals 70. And minus 3i1 plus 15i2 equal 80. Okay? If we write this in a matrix form, we can say simply 9 minus 3 minus 3, 15 times I1, I2 equal to 70, and this is 80. Okay? Now we can determine I1 and I2 easily. We can say determine delta, which is determinant of 9, the minus 3, and the minus 3, and the 15. So this will be 9 times 15 minus 3 times minus 3. So this will be 9 times 15 is 45, 13. Okay? 135 minus 9. So it will be 1, 2, 4. Right? And we find delta 1. Now, how to find delta 1? Delta 1, we replace the first column, which is 9 minus 3. This column here, we replace it with this column, 70 and 80. So 70 and 80 here. And we keep the other column, which is this one, minus 3 and 15. Okay? So this will be 70 times 15, so this here, okay, minus 3 times 80, so minus this one, okay? Now, this will be 0, 7 times 5 is 35, so 1 0. Okay, 70 times 15 is, okay, 7 times 15 is, yeah, okay. And minus times minus is plus, 3 times 80 is 240, okay. So this will be 0, 9, 2, 1. Right? Okay, now we determine delta 2, which is equal. We do the same. Now, delta 2, we replace, okay, we replace this column. We keep this column. This one, we keep it here, okay? So 9 minus 3. And we replace this column here with 70, 80. 70, 80. So this will be 9 times 80 minus 3 times 70, right? So this will be 0. 8 times 9 is, I think, 72. Minus times minus is plus. Right? 3 times 7, 21, 0. So it will be what? 0, 3, 9. 930. Now we say simply I1 equal delta 1 divided by delta. So this will be 1290 divided by delta, which is 124. 124, okay, ampere. And I2 is equal delta 2 divided by delta, which is equal 930 divided by 1 amps. So you determine I1, I2, and say I 3 ohms equal I1 minus I2. Okay? Fine? You do these calculations. I'll leave it to you. Okay? But this is the method. Okay? Now, let's go to another example. Let's write mesh equations for the following circuit. Okay, let's have a resistor here, another resistor here, another resistor here. Let's have another resistor here, another resistor here. Okay, let's have a battery source here, a battery source here, and let's say a resistor here. Okay, let's give them some values. 2 ohms, 4 ohms, 6 ohms, 8 ohms, 5 ohms, and 1 ohm, plus minus 10 volts, plus minus 15 volts, plus minus, let's say 9 volts. Now, we want to just write mesh equations or loop equations. Let's assign these loops here. Say this is I1, and this is here, I always in clockwise direction, I2, and this is another loop, let's say I3. Okay, so we have 3 loops, which means that we'll be having 3 equations. So what we want to write equations to solve I1, I2, and I3, to solve for, okay? So we want to solve for I1, I2, and I3. So we need 3 equations. So in the question here, in the example, write mesh equations. Only write them. I don't want you to solve. Just write the equations. So I say loop I1. Loop I1, we sum all of the resistors in the loop. We have the 1 and the 2 and the 5. So we say 1 plus 2 plus 5. Fine? Times I1. Now, I1 shares loop I2 with the 5 ohms resistor. So we say minus 5 I2. And it shares with I3 through the 2 ohms resistor. So say minus 3 I3. So it's with the 2 ohms resistor. So say minus 2 times I3 is equal to, how many voltage sources we have? The 10 volts, this 10 volts here, okay, 10 volts in the same direction, so we say 10, and we have the 15 volts in the opposite direction, so minus 15. Okay, so what we have here is 8 I1 minus 5 I2 minus 2i3 is equal minus 1. So this is equation 1. Okay? Now we go to loop I2. Loop I2. I2 is sharing I1 through the 5 ohm resistor. So it's minus 5i1 plus the sum of all resistors in this loop, which is 5, 6, 8. So 5 plus 6 plus 8 times I2 minus, you see minus here, minus there, plus only for the same loop current. It shares with I3 through the 6 ohm resistor, so minus 6 I3 is equal to, how many sources we have? Only the 15 volts, okay? Only the 15 volts, and it is in the same direction, so plus 15. So we have minus 5i1 plus 19 I2 minus 6 I3 equal 1, 5, and this is equation 2. Okay, now we go to loop I3. Loop I3, it shares, this is loop I3, it shares with I1 through resistor 2 ohms, so we say minus 2 I1 minus, and it shares I2 with I2 through the 6 ohms resistor, so minus 6 I2. Now I say plus because we are talking about loop I3, so it is a plus. All the resistors 2, 4, and 6, so 2 plus 4 plus 6 times I3 is equal to, how many sources we have? Only the 9 volts source, and it is in the opposite direction. This is the minus 9, or the 9 voltage source in the opposite direction is all of I3, so we say minus 9, minus 9. So we have minus 2i1 minus 6i2 plus 12i3 equal minus 9, and this is equation 3. So solve 1, 2, and 3 for I1, I2, and I3. Right? So this is basically how we apply mesh analysis. Okay? Let's take another example. I want you to show how example. The previous examples we had only voltage sources. Now let's have also a current source in a problem. Okay, so let's have 2 resistors here. Let's have a current source here, a resistor here, and a current source is not a voltage source, a current source. Let's have a voltage source here and another voltage source here. Okay, and let's give them 10 ohms, 20 ohms, and 5 ohms. Let's have 2 amps here, plus minus, let's say 30 volts, plus minus, let's say 120 volts. Okay, now we want to determine, find the current in the 10 ohms resistor using mesh analysis. Okay, and also determine the voltage across the current source. Okay? Now, if you have a current source in mesh analysis, you do it the same way, but be careful of the current source. Let's assign the loops here. We have two loops. This is I1 and this is the other loops, I2. So usually in mesh analysis, the first step you do, you assign the loop currents, okay? Then we apply KVL or mesh analysis theorem to both loop currents. So let's say loop I1. Now, how many resistors in loop I1 we have? We have 10 and 5. So we say 10 plus 5 times I1. It shares with I2 through the 5 ohms resistor, so minus 5 I2. Okay? Is equal to what we have, plus 120, but don't forget the voltage, the current source. So we don't know the voltage across the current source. So what we do, we come to the voltage source and say, okay, we may have here a voltage, let's call it Vx, okay? So Vx is in the opposite direction, so minus Vx, okay? And this is equation 1. Okay? Now let's go to loop I2. Minus 5 I2, I1 plus. So I2 shares with I1 through the 5 ohms resistors. And we have 5 and 20. So plus 5 and 20 times I2 is equal to, now what we have here, 30 is in the opposite direction, so it's minus 30. How about Vx in the same direction? So plus Vx. This is 2, right? Now look at equations 1 and 2. If we add them, we can get rid of Vx. Adding 1 and 2, so we have 10 plus 5 I1, and here minus 5 I1, we get 10 I1, right? And here we have minus 5 I2, here. And here we have 5 plus 20 I2, we get plus 20 I2, equal 120 minus 30, and minus Vx and plus Vx will go. So we have 10 I1 plus 20 I2 equal 120 minus 30 is 90. And let's say this is equation 3. Okay? In fact, what we have, 4 variables, I1, I2, and Vx. I1, I2, and Vx. But we get rid of Vx, we have 2 variables, I1 and I2, and we have a single equation. Okay? Basically, what we have, 4 variables, I1, I2, Vx. We need 3 equations. We have only 2 equations. But we added this and this to get rid of Vx and obtain only a single equation. So the extra equation we need, we can get it from the current source. If you look at the current source, we have a current here, 2 amps. 2 amps in the same direction of I2, and it is the opposite direction of I1. So what we can say here, from, okay, the current source source, we have 2 amps is equal I2 minus I1, right? I2 positive and I1 negative. So we have I2 minus I1 equal to, and this is the equation. Okay? So solve equation 3 and 4. We can solve it easily by substituting I2 is equal to plus I1 and substitute this into this equation. We'll get 10 I1 plus 20 I2, which is 2 plus I1 equal 90. So simply we say 10 I1 plus 40 plus 20 I1 equal 90. Then we'll get what? Here 20 I1, okay, 20 I1. And so we have 30 I1 equal 90 minus 50, minus 40, sorry, minus 40, okay. So minus 40, so equal 50, right? So you get I1 equal 50 over 30 equal 5 over 3. Okay? So what is the question is find the current in the 10 ohms resistor. So that's I1. Okay? So I1 equal I 10 ohms. Okay? And the second part of the questions also determine the voltage across the current source, which means Vx. Okay? Voltage across the current source is Vx. So Vx equal what? So we can go back to equation 1 or 2. Okay? Use equation 1 or 2 to determine Vx. If we use 1, then 1 says simply 10 plus 5 I1, 10 plus 5 I1, okay, minus 5 I2, minus 5 I2 is equal 120 minus Vx equal 120 minus Vx. Okay, now we know I1, so this is 15 I1 minus 5 I2 equal 120 minus Vx. I1 equal, we have calculated 5 over 3. We need to calculate I2, which is equal, from this equation, I2 is equal 2 plus I1. 2 plus I1, which is equal 2 plus 5 over 3, which is equal 3, 11, right? 11 over 3 amps. So we say, now 15 times I1, which is 5 over 3, okay, minus 5 I2, which is 5 times 11 over 3, okay, equal 120 minus Vx, okay. So here we have 5 times 5 is 25 minus 55 over 3 equal 120 minus Vx. So Vx is equal 120 minus 25 plus 55 over 3. Okay, so this will be 75. Okay, here minus, so it goes to plus there. Okay, 75 plus 55 over 3, and you can calculate it. So to summarize, we have a voltage, a current source in the circuit. We assign a voltage Vx across that current source, and we do the loop. We don't forget to put Vx in the loop as well. So we make for the loops two equations, add them to get rid of Vx, and the other equations you need is from the current source, I1 minus I2 equal minus 2 here, okay? And if we want to determine Vx, we substitute I1 and I2 we obtain in either equation 1 or 2. So that's basically the method of mesh analysis. Now I'll go we'll demonstrate nodal analysis. To nodal analysis. Nodal analysis, we apply KCL, Kirchhoff's current law, to determine node voltage. Okay. In the mesh analysis, we determine loop currents. In nodal analysis, we determine node voltage. So, if we have a resistance here, 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 let's assume that we have a ground here, a ground here, a ground here, okay? Let's have a current source connected between the ground, let's say I1, another current source connected between the ground, another current source connected between the ground and this one. How many nodes here we have? 3 nodes. Say V1, V2, and V3. Let's assume that we have also a resistor here. Let's say here R1, R2, okay, R3, R4, R5, and R6. We have total of 6 resistors, okay? Now, we want to determine, find V1, V2, and V3, i.e. this node voltage. So we have 3 nodes, means we need 3 equations. We apply KCL, applied to node 1 or node V1. So if we apply KCL to node V1, we'll obtain the currents, okay, I1 equal V1 over R1, that's the current passing here, okay, plus the currents passing in R4, which is V1 minus V4, V2 divided by R4, okay, plus the current passing in R6, this is in R4, current in R4, and this is current in R6, and this, so plus V1 minus V3, divided by R6. Now if we simplify this, see V1 here over R1, V1 here over R4, V1 here over R6. So we simply say 1 over R1 plus 1 over R4 plus 1 over R6 times V1. Okay? And here we have minus V2, 1 over R4 times V2. And again, minus V3, 1 over R6. V3 is equal to I1. If we look at it here, what we did, for node V1 equations, we took all the resistors connected to that node, which is R1, R4, R6, and sum 1 over 1 over R1 plus 1 over R4 plus 1 over times V1. Then minus the resistor, one of the resistor connected between V1 and V2 times V2, minus 1 of the resistor connected between V1 and V3, okay, which is R6, equal the sum of currents injected in node I1, which is I1. Okay, we can apply to node I2, node V2. Now minus V2 is connected to V1 through R4, so we say minus 1 over R4 V1. Now plus 1 over. Now we have R2, R4, and R5. So R2 plus 1 over R4 plus 1 over R5 times V2 minus. Now with V3 is what? Is R5, so minus 1 over R5 V3 is equal to I2, because I2 is ejected to that node. We apply this to node 3 or V3, okay, minus 1 over. Now V3 is connected to V1 through R6, so we say minus 1 over R6 V1 minus. Connected with V2 through R5, so minus 1 over R5 V2 plus the sum of all of them. What we have, R3, R5, and R6. 1 over R3 plus 1 over R5 plus 1 over R6 times V3. And this is equal I3. Okay? So this is the basic steps we apply to the nodal voltage. We use nodal, the method of nodal analysis. Okay, let's demonstrate that in an example. Let's take an example. Okay. Let's have two nodes, okay? This is a node and this is a node. And let's have a resistor here of 10 ohms. Let's have a resistor here of 20 ohms. Let's have a resistor here of 50 ohms. Okay? Connect this to ground, connect this to ground. Let's have a 2 amps here, connected to ground, and let's have a current source here in this direction of, let's say, 5 amps. Okay, so basically this is the circuit. How many nodes we have? We have 2 nodes. Let's say this is V1 and this is V2. So determine the current in the 50 ohms resistor using nodal analysis. Okay, so we want to use nodal analysis to determine the current in the 50 ohms resistor. Let's say this is I 50 ohm. So I 50 ohm is simply 1 over 50 times V1 minus V2. So we need V1 and V2. Okay? Let's determine V1 and V2. Say node V1. How many resistors we have? 50 and we have 10. So we say 1 over 10 plus 1 over 50 times V1 minus. It's connected to node V2 through 50 ohms, so minus 1 over 50 times V2 is equal to the injected currents. The injected currents, okay, the injected currents is 2 amps and 5 amps. 2 amps in, 5 amps out, so we say 2 minus 5. Okay? So what we have here, 1 over 10 plus 1 over 50. Okay? So what we'll obtain, we can multiply by 50 if we like, so we'll get here 5 plus 1 times 1, okay, minus V2 equal minus 3 times 50, right? We multiply both sides. 2 minus 5 will get minus 3. We multiply both sides by 50, okay, so you get 6V1 minus V2 equal minus 150. And this is equation 1. Okay? Now, we go to node 2. V2. Node V2 is connected minus 1 over 50. V1, V2 is connected to V1 through the 50 ohms, so we have minus 1 over 50. Then we have 50 and 20, so we say plus 1 over 50 plus 1 over 20. Okay? Times V2 is equal. Now, how many currents? We have 5 ohms, 5 amps, and it's injected in node V2. So we say plus 5. Okay? Now we can multiply by 50 if you like. Okay? So if you multiply by 50, then you get minus V1 plus 1, okay, plus 50 over 20, 5 over 2, which is 2.5, V2 equal 5 times 50. So minus V1 plus 3.5 V2 equal to 50, and this is equation 2. So simply we can solve equations 1 and 2 to determine V1 and V2. Okay, I will leave that to you. Solve 1 and 2 to determine V1. Okay, you can do it either way, by the determinants method or just simple okay, application. Let's take another example. Okay. Write noodle equations for the following circuit. Okay, we want just to write noodle equations for the following circuits. Let's assume that we have here a current source of 5 amps, a resistance here, okay, another resistance here, a resistance here, a resistance here, a node here. Let's have also another resistance here. Let's assume that we have a resistance here also. Let's give them, and let's have a current source here. Okay. Let's assemble. Here we have 2 amps. Let's give it a direction here, say 5 amps. Okay. Let's have here 10 ohms, 20 ohms, 30 ohms, 40 ohms, and 50 ohms. Okay. Now, how many nodes we have in this circuit? Simply we have 3 nodes. Just node 1, node 2, node 3. Let's say V1 here, we have V2 here, and V3 here. Okay? Now, let's write the nodal equations. Node V1. How many resistors we have in node V1? We have 50 connected, only the 50 and 10. So we say 1 over 50 plus 1 over 10 times V1. Okay? Now it's connected to V2 through 50, so we say minus 1 over 50 V2. Is it connected to V3? Through a resistor? No, we don't have any resistor, which means we have an infinite resistor. So we say minus 0 V3. We don't have anything connected. Actually, so this zero actually here is 1 over infinity, because we have an infinite resistance connected between these two nodes, so it's 0. Is equal to injected currents. We have only the 5 amps, this 5 amps coming out, so we say minus 5. Okay? So we have simply 1 over 50 plus 1 over 10 times V1. Okay? Minus 1 over 50 times V2 equal minus 5. And this is equation 1. Okay? Now let's go to equation 2. Our node V2. Node V2 is connected to node V1 through the 50 ohms resistor. So let's say minus 1 over 50 V1, right? And then we say plus, how many resistors we have? We have 50, 40, and 20. So 1 over 20 plus 1 over 40 plus 1 over 50 times V2. All these connected to V2. This is 20 here, and this 50 here, and this 40 here. Okay? Then it is connected to V3 is through the 40. So minus 1 over 40 V3 is equal the current's 2 amps, which is injected in it, 2. Okay, so we have equation 2 here. Okay, now we go to node 3, node V3. Okay, node V3, it is connected with V1 through an infinite resistor, so we have minus 0 times V1 minus connected to V2 through the 40 minus 1 over 40 V2. Now say plus, because we are writing the equation of node V3. We have a 40 and a 30. 1 over 40 plus 1 over 30. Okay, 40 and we have the 5 amps M equal 5. So this is equal 5. So what we have, minus 1 over 40 V2 plus 1 over 40 plus 1 over 30 V3 is equal to 1, and this is equation 3. Okay, so this is the way how we write equations. Now let's take an example that contains a voltage source. Sometimes you may have that example. Let's have a current source here, a resistance here, another resistance here. Okay, and let's have a resistance here. Okay, between these two we can say we have only one resistor. Okay, one resistor here. Okay, let's have one resistor here connected here. Okay, let's give it a voltage source somewhere. Okay, let's give it a voltage source here, for example. Okay, just for the sake of the solution. Okay, we have a voltage source here. Okay, now let's say we have here plus minus 10 volts, and we have V1 here, V2 here, and V3 here. Let's have 10 ohms, 20 ohms, 50 ohms, 100 ohms. Let's have 2 amps here and 3 amps here. Okay, this is simple circuit. When you see ground here, ground here, ground here, it means all these are connected together, right? Okay, now find V1, V2, and V3. Okay, from the circuits we already know V2. Simply say V2 equal 10 volts. Why? Because the battery source here plus minus 10 volts means V2 is 10 volts. So we know it. We don't need an equation. So simply what we say is node 1 V1 S 1 over 100 plus 1 over 10 That's times V1 minus, okay, 1 over 10 times V2 minus 0 times V3 equal 2 amps, right? So we can calculate it easily, okay? V2 is 0, and this one here is 10 volts. So we determine V1 directly, okay? So this 0 is not V3, 0 times V3 will give you 0, okay? So we can simply determine V1. And if we do it this way, we say simply 1 over 100 plus 1 over 10 times V1 equal to minus will go there plus 1 over 10 times 10, okay? Which is equal 3. Find V1 equal what, okay? Very simple. So that's equation for, when you come to node 2, V2, simply say V2 equal 10 volts. So that's why we use it here, okay? Because we know it. And when we come to node V3, we do the same. V3, we have 50 and 20. So we say plus 1 over 50 plus 1 over 20 times V3. And this is connected to V2 through 20. So minus 1 over 20 V2. And it's not connected to V1. There's no resistance V1. So minus 0 times V1. Okay? So simply, and this is equal what? Equal 3 amps. Equal 3. Okay? So 1 over 50 plus 1 over 20, is that 20? 10, 50, yes. Okay, 50 and 20. Okay, times V3 equal 3 plus 1 over 20 times V2. So equal 3 plus 1 over 20 times V2, which is 10. So it is equal 3.5. Okay? And from this, find V3 equal what? Okay? It's very simple. Let's take another example. Okay? Let's now, I want to give you a voltage source between two nodes, okay? Now, it's very simple. Let's assume that I have a resistance here, a voltage source here, a resistance here, and a resistance here. Okay? Let's assume that we have a current source here. Okay? All right. Let's give them some values. Let's say we have 10 ohms here, 20 ohms here, 30 ohms here. Let's give this a value, minus say 12 volts. Okay? And let's say here 5 amps. Now, determine okay, determine let's say the determine V1 and V2. Okay, this is V1 and this is V2. Fine. Now, if you see that we have a 12 volts here, this means V1 minus V2 is 12. But we don't know what is V1. We don't know what is V2. All what we know from this voltage source, that's V1 minus V2 is 12 volts. So how to write nodal equations? We simply say node V1. How many resistors we have in node V1? We have 10 and 30. So we say 1 over 10 plus 1 over 30 times V1. Connected to V2, so 30 minus V2 equal to, do we have a current source here? We don't have a current source, but we have a current in the voltage source. So what we do, as before, we assume that we have a current here, and we call it Ix. So in this case, what we have here, Ix is coming out of V1, so simply we say this is equal minus Ix, because Ix is coming out, okay? So this is equation what? 1. Now, we go to node 2. Node 2 is connected to node V1 through 30, so we say minus 1 over 30 V1 plus. Now we have 30 and 20, 1 over 30 plus 1 over 20 V2 equal. We have 5 amps injected, and also what we have, Ix here is the same. This is Ix, right? Injected also, right? So both are, so what we have plus Ix, and this is equation 2. Now, if we adding 1 and 2, we can cancel Ix. So 1 over 10 plus 1 over 30 V1 minus 1 over 30 V1 will get 1 over 10 V1. Then here minus 1 over 30, and here plus 1 over 30 plus 1 over 20 plus 1 over 20 V2 equal minus Ix plus 5 plus Ix equal 5, right? And this is equation 3, okay? Now we need another equation. The other equation we obtain it from the voltage source, which is V1 minus V2 equal, V1 minus V2 is equal 12. Okay? So solve 3 and 4. Okay? We solve 3 and 4 to determine V3, V1, and V2. It's very simple. Okay? So when we have a voltage source in the circuit, which which we want to analyze using nodal analysis, we assume a current Ix flowing either in or out from the voltage supply, okay? So determine V1 and 2. And if we add here also find the current supplied by the voltage source, okay, which means this Ix equal what? Okay, then we either use 1 or 2. Okay, substitute V1 and V2 in 1 or 2 to determine Is. Okay, so I will end up this video here. You know now mesh analysis and nodal analysis, you can apply them in circuits. Okay, I will make a short video later on for you to demonstrate how we calculate the power supplied by voltage sources and supplied by current sources and consumed or dissipated in resistors. Okay? Okay, talk to you later.